Constructing an altitude for a triangle. An altitude is a segment that connects a vertex to the opposite side and intersects, forming right angles. You will often hear the phrase, an altitude is perpendicular to the base of the triangle. So that's a phrase that you might hear. So let me get a triangle. Okay, so we have vertices A, B, and C. And then you're going to be instructed to draw or construct the altitude to side AC. So from B to side AC. It needs to be perpendicular to the base. So I'm just going to go ahead and show you kind of where it is so you can see that we have this like right angle right here. But and what's really important, it was about right here, which is not the midpoint of AC. So we're not using the perpendicular bisector at all. However, we do need to perpendicular something. So what are our other options? We learned how to do perpendicular from a point on a line, but there's no point on AC. That's actually what we need to find. But we can do perpendicular to a given line from a point off the line. So our construction that we're utilizing is perpendicular from a point not on the line. All right, so how do we do this? The perpendicular from a point not on the line always starts with the smiley face. So for the smile, you're going to put your center on B because the smile has to go across AC. Now, I actually just said it has to go across AC. I can extend AC in case I need it to be extended, or I could extend after the fact. When I go to make this arc right here, and I'm going to put my center on B, I need to make sure, like somebody asked me earlier today, where does my slider go? Well, if it's up here, you're not going to cross AC. If it's touching AC, you're just going to touch once, and that's not going to work either. We need to touch in multiple places, so you're going to want to go far enough that your arc is big enough, but not too big. I know. It's like the three bears, too hot, too cold, just right. So this is just right for me because I can clearly see now that I have this point and this point that are the same distance from B, and that is the line I'm bisecting. I'm doing the perpendicular bisect for. So if I call this X and Y, I'm now focused on doing the perpendicular bisector of XY. So how do I do a perpendicular bisector? Just like we do in median, we focus on the endpoints of the segment we're bisecting. I want to make sure that I'm open more than halfway. You can make the entire thing if you'd like to, or you can just do the one underneath. So if I make the entire one, I've had some requests for this. Here we go. I got one. And then I go to the other end. I'm going to turn my paper to make sure I don't bump. Here is my other arc. And this is what should happen. what should happen is B aligns with that point, which aligns with this point. It's pretty good. That if you don't do this top one, you don't see that margin of error. Margin of error means it's not perfect, but it's close enough. And when you're drawing with a plastic tool and a pencil and a pen and a marker, we have some errors that are minimal and are okay. So I'm going to line up with this point and this point right down here, this intersection point. And I'm going to draw my altitude. Actually, first what I'm going to do is just dash in this line, which is the perpendicular bisector. Okay, that's the perpendicular bisector. The altitude is only within the triangle, so technically the altitude is from B to this point of intersection. I'm going to call it D. So right there, I'm going to draw a right angle marker because that is truly what is happening. We know that BD is perpendicular to AC because it is the altitude of triangle ABC.